So, hello students, we are here to solve the question from Spearman's rank correlation coefficient method, and we are on case 3. Okay, so the case 1 we saw that we were given the ranks and we were just finding the answer by putting all everything in the formula. In case 2 we see that we did not get any ranks, but we assigned them, and the ranks were simple, like assigning ranks were simple. Now in case 3 you'll have to do two things, like one thing only, you have to assign the ranks. But now in this case, may a single variable say x or the both the variables say y will have similar numbers. So in similar numbers you will have to assign similar ranks. Okay, so this type of case is called when we tie up the rank, uh, tie up the rank or tied ranks. Okay, now for this case only the formula changes, and the formula changes so easy that you will just remember it here only by seeing this video only. Now in the previous methods what we uh, did was what formula we used was 1 minus 6 sigma d square upon n square minus 1. It wasn't it? Now just one thing will add up in this whole formulas is CF. Now this CF is not cumulative frequency, this is correction factor. Okay, so the formula is 1 minus 6 sigma d square plus CF. It is in the bracket, so that means that you have to find this and add CF before multiplying it by 6. Divide by n square minus 1. Now how will we calculate CF? By this. CF will be equals to M1, M2, M3. What are M1, M2, M3? These are the, okay, so M1 will be, acha, you will understand it by the by understanding when we'll solve the question. Okay, so first just memorize this formula because this is the same for M2, M3 and n numbers of M. Okay, M1 bracket M1 square minus 1 upon 12. 12 will be always there no matter what your n is, no matter what changes, L 12 is the constant. M2 bracket M2 square minus 1 upon 12. M3 square minus 1 upon 12. Okay, I hope you got it. Now let's see a question and solve this. So here in these value of x and y variable, you will see that there are many numbers that are repeating for many times, like the number 60 is repeating for 3 times, the number 50 is repeating for 2 times, and here in this y variable also you can see that the number 130 is repeating for 2 times. Now let me just show you how do we calculate CF first. Okay, because everything else is like we already know that. Okay, now what you have to do is first assign the ranks. Now for ranks x and for rank y, now assigning rank is also a good task here, is also a difficult task here, I will say, but it is not that difficult. It looks difficult, it is simple, super easy it is. Now let's assign the ranks of x variable. Acha, let's assign the ranks of y variable first. Okay, now which number is the highest number? It is 210. So 1 2 and then 3 4 and then comes 130. Okay, so how many numbers are there? There are two numbers. What ranks are to be assigned if there were different numbers? 5th and 6th. So add rank 5 and rank 6 divided by 2 because there are only two numbers. So 11 divided by 2 is 5.5. Assign this rank 5.5 to both the numbers. Easy, wasn't it? So, and assume that we have already used the rank 5 and rank 6. So, do not start from 6, now start from 7. So, assign the number 7 here, rank 8 here. Now, do the same for x variable. Here it is the highest, then second, and then for third there are 3 candidates for the third rank. So, if they were different, what other ranks would they get? Third, fourth and fifth. Add these. Third, fourth and fifth. Divide by 3 numbers because there are 3 candidates. 3 plus 4, 7. 7 plus 5 is 12. 12 divided by 3 is 4. Assign the rank 4 to all of them. Now, you have to skip the ranks till 5. Start from rank 6. So, rank 6, there are again 2 candidates for rank 6. Now add the rank 6 and the otherwise rank 7 divided by 2 because there are only 2 candidates. So 6 plus 7 is 30. 13 divided by 2 is 6.5. Assign the rank 6.5 to both. Assume that the 7th rank is also used. Now assign the last rank 8. Now what you have to do is find the deviations. Deviation 0, 0.5, 0, 1, minus 4.5, 4.5 positive, this time 1 and minus 1.5. Square the deviations. 0, 0 0.25, 0, 1, 4, 5. Instead of multiplying it, do it by the simple formula 25. Calculate the square of 5, then the square of 4, 16. Multiply by 4 and 5 together, that would 20, double it 40. Now calculate it. 5202 2025, and how many decimals, after how many decimals we have to use the decimal, like after how many places? Okay, sorry for that, after 2 places. So that is 20.25, again 20.25, 1 and 1.25, that means 2.25. Now we know that the sum of d square will be 2.25 plus 0.25, 2.50, 3.50, 4.50, 4.50 plus 50, that is 5 and 20, 45, 20 and 20, 40 and 45. So sigma d square came as 45. Now we know everything about the formula, as we know that there are 8 total numbers, so the n will be equals to 8. Sigma d square is 45. What we don't know is CF, and how do we calculate it? We add M1, M2 and M3. Now how would we calculate M1, M2 and M3? So what you have to do is pay attention from here. Now see that the first variable that was repeating itself was 60. Okay, right? It was 60. So M1 is 60. We'll calculate M1 by using 60. Do not confuse it here, okay? We'll calculate M1 by 60. Now in this x variable, the number 50 was also repeating. The number 50 was also repeating. Okay. And how many times was 60 repeating? It was repeating for 3 times. For how many times 50 was repeating? It was repeating for 2 times. In the y variable, now there is nothing that is repeating. Okay, oh, by mistake I did so. Okay, so in the y variable, 130 is repeating, but for how many times? For 2 times. Okay, I hope you got it till here. Let me just wipe this page out. Okay, so M1, in M1 60 is repeating for 3 times. For M2 50 is repeating for 2 times, and for M3 130 is repeating for 2 times. What our formula says is to calculate M1 using M1 upon sorry, bracket m1 square minus 1 upon 12. This was the whole formula for m1. Same for m2, same for m3. You just have to uh, replace the numbers only from here and here. Okay. Now, it is the crucial part that this is of no use for calculation of m1, because we just have to take this into the consideration. Just for the easiness, I wrote this. Okay. Now, calculate m1. m1 was 60, it repeated for 3 times, so m1 is equals to 3. Now calculate it. 3 square is 9 minus 1 upon 12. 3 8 upon 12, it is 24 upon 12, it is 2. m1 is equals to 2. m2, let's calculate it. m2 minus bracket m2 square minus 1 upon 12. Write it as much time as you can. Okay, write it for as much time as you can. Now m2 is 2, and the same value will come for m3 also, because it is also repeating for 2 times. So we will assume that this value is thus. What is the purpose of assuming this? These value will come as same. Okay, so 2 is 2 square is 4 minus 1 upon 2. 2 is equals to 2 3 upon 2, that is 6 upon 2. 6 upon 12. Okay, 6 upon 12, it means 0.5. So m2 would be equals to 0.5, m3 would be equals to 0.5 again, because we don't have to consider these values that are differing. These are the values that we need to consider. Okay, it is simple beta. You just have to like practice it for few times, and you'll be like water. So CF will be equals to m1 plus m2 plus m3, that is 2 plus 0.5 plus 0.5, it is 3. Now let's put everything in the formula. 1 minus 6 sigma d square minus CF upon n square minus 1. Now, as we have already calculated that our plus है, okay, for sigma d square is 45, CF is 3, n is 8.